Hello, great people. Welcome to today's math class. Today we have this challenge before us here. It's a simple one. Okay. So we have some symbols here and a numerator here. And I believe most persons are used to this, they know these symbols here in mathematics. But today let's look at this. So we have the symbol of factorial, but this time around, it comes before the numerator. Okay. Unlike the one we used to have that appear after the numeral, but this one comes before the numeral. So this is a different symbol, and here we have the hashtag in computer world, but in mathematics, it is not the hashtag. Okay, so we're going to take a look at these two symbols, their names, and how to evaluate them. So let's take a selection here first thing first. Okay, now, but before we continue, if you're new here, this is Online Maths TV, and if you've not subscribed, kindly subscribe, and when you subscribe, turn on the notification bell because we bring out videos all the time so that you'll be among the first to get our videos whenever our video is released. All right, now how do we now read this? This is what we call the subfactorial, and this is what we call the primorial. Okay, so the question here is telling us to evaluate the subfactorial of 3 primorial. Subfactorial 3 primorial. So we know that the factorial symbol, if you are given something of this kind, let's assume you have 2 factorial. This means 2 times 1, which is equals to what? 2, right? Then if we have 3 factorial, this is equals to 3 times 2 times 1, which is equals to what? 6 here, right? Good. So this is what we mean by what? A factorial, right? Good. But here we are having what is called the subfactorial. So what does this subfactorial means here now? It is easy. It means the different way of arranging a given number without each of these numbers assuming the previous or the same position. Clear? Right? The subfactorial means different ways of arranging a particular number without that is particular set of numbers without each of these numbers assuming the same position or the previous position. Okay, but we have a common expression to kind of find the subfactorials of a figure. For instance, if we have our x subfactorials of x, all right, the subfactorials of x, this means our x factorial bracket our 1 all over 0 factorial, then minus our 1 all over 1 factorial, then plus 1 all over 2 factorials, then minus 1 all over 3 factorials, then plus dash until we get to plus our 1 all over the x factorial itself. So this is the simplest expression for our subfactorials. So if you are given any number to find the subfactorials of it, you can do this. With this, you're going to get the number of times you arrange that particular set of numbers or that number without each of them assuming the same position, right? Good. Now the next one here is this hashtag here. Yeah, it looks like the currency symbol in my country. If you join this top to this bottom here, it gives you the symbol in my currency, okay, which is called the naira. But here we call it the primorial. What does primorial means? For instance, if we are given a number of this kind, 2 primorial, so we have to look for all the primals in this system. So what does it mean? We have to consider the number from 2 to 1. And we bring out all the prime numbers and multiply them together. And so these 2 primorial is going to give us 2. The next figure is supposed to be 1, but 1 is not a prime number. So 2 primorial is just equals to 2. Let's take another example, which is, let's say, if we have 3 primorial, what does this mean? So the first number here is 3, and 3 is a prime number. So we're going to have here 3, then times, the next number is 2. Is 2 a prime number? Yes, 2 is a prime number. There times 2. The next number is 1, and 1 is not a prime number, so we don't consider 1. And so this is equal to 6. So it means 3 primorial is equal to the primals multiplying themselves, which is 3 times 2 to give us what? 6. Now let's come to our question here. Look at our question here. We are having the subfactorial of 3, the primorial. So how are we going to handle this? How are we going to solve from this side backward, or we are going to start from the subfactorial backward? Okay, so in handling this, we start from the primorial side. So we solve backward here. So solving backward, it means we have to look for three primorials. Three primorials, right? So looking for three primorials, then look at what we have here. We've already gotten it here. So three primals or three primorial will give us 3 times 2, which is equals to 6. And so this is going to give us here our subfactorial of what? R6. Okay, with what we have in here now, right? Good. So if you want me to express it out first, then this is going to give us our 3 times our 2, which is equals to the subfactorial of 6. Okay, so now we've gotten the primals of 3 here. Then what we do, we now look for the subfactorial of 6. Having this expression here, or apply this expression, so let's come here and write it. So we know that our subfactorial of 6 is equals to the 6 factorial bracket 1 all over 0 factorial minus 1 all over 1 factorial plus our 1 all over 2 factorial minus 1 all over 3 factorial plus 1 all over 4 factorial, then minus 1 all over 5 factorial plus our 1 all over 6 factorial, close bracket. Okay, so from here, we have to look for our 0 factorial. We know 0 factorial is equal to 1. So this is going to give us our 6 factorial bracket 1 all over 1, then minus, and also 1 factorial is equal to 1 also. So we have here 1 all over 1, then plus our 2 factorial will give us 2 times 1, which is equals to 2, then minus 1 all over our 3 factorial is 6, because that will give us 3 times 2 times 1, which is 6, then plus our 1 all over the 4 factorial will give us 4 times 3. 4 times 3 will give us 12. 12 times 2 will give us 24. Times 1 will still give us 24. All right, there, minus 1 all over. Our 5 factorial will give us 5 times 4, which is 20, times 3, which is 60, times 2, which is 120. So we have this to be 120. The plus the last one, which is 6 factorial. 6 factorial will give us 6 times 5, which will give us 30. 30 times 4 will give us 120. 120 times 3 will give us 360. And 360 times 2 will give us 720. 720 times 1 will give us 720. So we have here 720, close bracket. Wow. So now we have this. The first thing we're going to do here, or what we observe here, is this. Here we are having 1 all over 1 minus 1 all over 1. So we can cancel out. So if we cancel out here, then we are now left with this expression here. So this is going to give us our 6 factorial. The bracket here, we're going to have here 1 all over 2 minus 1 all over 6 plus our 1 all over 24. Then minus 1 all over 120. Then plus our 1 all over 720. Right. Okay. So what we do in this case here now, we just have to find the LCM of the numbers we have at the denominator here, right? So finding the LCM, this is going to give us our 6 factorial, then bracket. Let's draw a very long line here. So we have 720, close bracket here. So we're going to use 2 to divide this. So 2 into 7 will give us 3 rather. Then bring 1 here to give us 12. So 2 into 12 will give us our 6 here. So we have 6 there into 0. Then minus. We use 6 to divide our 720. So 6 into 7 will give us 1. Then bring down 1 here to give us 12. So 6 into 12 will give us 2. Then we have our 0 here. Then we come to the next one. Then if you use 24 to divide 720, that will give us plus 30, right? Okay, so we have plus 30. Then if we use 120 to divide our 720, that will give us 6. So we have here minus 6. And if you use 720 to divide 720, will give us plus 1. Okay, I want to believe this is visible, right? Good. So from here, we can now do the simple addition here. All right, so let's continue this expression down here. So this is going to give us here our 6 factorial, because mind you, we are having the sub factorial of 6 will now be equals to 6 factorial, the bracket. Yeah, let's do our addition. This is plus, and this is plus. So if we add this to this will give us 390 plus 1, 391. So we have here 391, right? Then the subtraction side of it is going to give us minus 120, minus 6 will give us minus 126. So we have here minus 126, right? Over there we have our 720. Good. I believe there's no confusion here, right? All right, so we forge ahead again. So if we have to subtract, so we're going to have 6 factorial, the bracket. If we take 6 from 1, cannot borrow 1 from here, here gives us 8, and here we have 11 here. So 6 from 11 gives us 5. Then we have 2 from 8, that will give us 6. And here we have 1 from 3, will give us 2. Then all over our 720 close bracket. Now remember, here, this figure we have here is gotten from our 6 factorial, right? So if this is equivalent to 6 factorial and we are having 6 factorial here, so what happens? So this will go with this. So we are now therefore left with the subfactorial of 6 will now be equal to our 265. So in all, let's come to the original equation which we have here. So we're going to have here the subfactorial of 3. So we have here subfactorial of 3, the primo will now be equal to 265. So this is the answer when you evaluate the subfactorial of 3 primo. All right, so this brings us to the end of this math class. Yeah, I believe you must have learned something from this video tutorial. If you do, then give the video a thumbs up. And if you're not subscribed, do not forget to subscribe. This is Online Maths TV, and we love you dearly. If you have any question with regards to this expression or this solution here, drop it in the comment section and I'm going to meet you there. Thank you for being there all the time. I love you. Keep watching Online Maths TV and to meet you in our next class. Keep winning. Bye for now.